Hi everyone, my name is Jenna Goldberg and I'm a designer on the augmented reality team at IBM. Today I'm going to be showing you how we're transforming the world of data analytics using AR, as well as one of our early success stories. And later on, my colleague Reena Ganga is going to walk you through some of the design challenges that we've faced along the way and how we've navigated through those various pain points. I'll start off with a fact. Humans generate 2.5 million terabytes of data per day. Companies are discovering the power that lies within their consumer data, and they're hiring analysts to help them understand this information better so they can make better business decisions. Bernard Marr quoted in a Forbes article that more data has been created over the past 2 years than in the entire previous history of the human race. Data volumes are exploding, and the data that's available to organizations is going to keep growing as we continue to find new ways to generate it. So the companies that can figure out how to stay on top of this information, analyze it faster, and find those insights are the ones that are going to come out ahead. That's why our product is so valuable. Currently, data analysts are using tools similar to this to find their insights. It's typical for them to have long spreadsheets, multiple 2D dashboards, and several graphs that are hard to understand. Due to this drawn-out process, it takes them a really long time to find the insights they search for. How would things change if we had the ability to look at this information in 3D? Let's imagine that all of the data for each business is a single building block. With existing tools, it's hard to get a grasp of what the entire block looks like. Here, visualizing the block from a different angle lends information on its depth and the number of dots. And maybe some other bricks might even be hidden behind it. A new perspective doesn't just allow you to understand one brick. It reveals the entire system. With a 3D view, you can see things that were hidden before. So if we took this Lego analogy and turned it into a real tool, here's what it would look like. Analysts could look at their data in three-dimensional space, walk around it, and interact with it in a more intuitive way. Instead of taking, say, 3 days to discover an important piece of information, they could do it in 3 hours instead. Having this extra time would lead to so many more insights, which ultimately would allow businesses to make these key decisions more efficiently. This is what we're doing at IBM. We're making this vision a reality with a product called Immersive Insights. Now I'll show you why we decided to build this product and how it's already been used to create positive change. The way it got started is a pretty cool story. David Townsend, the director of design for hybrid cloud at IBM, sent out a challenge to all IBM designers globally that was simply to learn some new technology. And he said, once you come up with something that we can make from it, come talk to me and we'll see how we can turn this into a project. And Alfredo Ruiz, who is now the design lead for Immersive Insights, immediately took interest and started asking himself some questions. First off, IBM is an enterprise software company, not a content company like Disney or Facebook. So with every product, we aim to create something that seamlessly blends into an organization's workflow. So as an IBM employee, the first practical thing to ask is, where can enterprise software be improved? As you could probably guess by my introduction, Alfredo found that data analysis is both important to all types of businesses and desperately needed technological improvement. So what's wrong with current data analysis methods? I would compare today's tools to using a flip phone to read a novel. It can be done, but there's definitely a better way to do it. Today's tools are time-consuming, overwhelming, and difficult to uncover insights with. So Alfredo decided he was going to find a way to improve data analysis. Now he had to figure out what kind of technology he was going to use to do this. He realized that so far, AR and VR have been primarily successful in the gaming and entertainment industry. In fact, gaming has been known to be ahead of the curve in technology. So he asked himself, if AR and VR are at the cutting edge of technology, Why are they only being used for entertainment purposes? Why aren't people using AR and VR in the enterprise industry? The technology was there, and he felt it was up to him to find out how to leverage its potential. So he really saw a lot of potential in being able to combine digital and physical objects, and he thought this was the perfect gateway to doing just that. Now the question was, which one, AR or VR? For enterprise applications specifically, it's important to be able to communicate with others. And the primary benefit of AR is that it's less isolating. If an analyst is interacting with data for hours on end, they're going to want to feel comfortable in their environment and be aware of their surroundings. Let's say you're looking at a data visualization with some of your coworkers. In AR, you could all be sitting around the table looking at it together, as opposed to looking at virtual avatars of each other in a VR setting. So for these reasons, Alfredo decided to pursue the product using AR. It allows the users to remain present in their environment, it enables access to a much wider user base, and it has collaborative capabilities, all of which are crucial to the intended users. So he got to work and Immersive Insights was born. Now we have a global team that consists of 8 of us spread out amongst San Jose, Austin, Boston, and Germany. We've been working on the app for a total of 2 years, and we're going to be launching a beta version soon. So Immersive Insights is an augmented reality tool that allows users to explore and visualize data in 3-dimensional space. It was made with the intention of creating a tool for data scientists and executives to understand their data faster. With these immersive visualizations, our users can identify relationships and patterns and easily drill in on the most meaningful information. So by placing them in this 3D AR environment, we are hoping that they can interact with the data in a more instinctive fashion so that they can easily navigate through this data exploration process and have more time to focus on the insights themselves. Now I'm going to show you an example of how Immersive Insights has already been put to use. Meet Ari Kaplan. Ari analyzes data for a living, specifically Major League Baseball data. So quick show of hands, who here has heard of Moneyball before? That's a good amount, okay. I had not heard of it before this. So for those of you who haven't, Moneyball is a strategy. Both the novel and the movie are based on a true story of how people realized that they could use the power of analytics to build winning baseball teams. They do this by sorting through tons of information on baseball players that have been deemed as having little value to a team. And they search for specific skills for these players that complement each other, and they combine these skills to create this winning baseball team at a reasonable price. We like to consider Ari the modern-day Mr. Moneyball. He's using this strategy to create these winning Major League Baseball teams today. So if you see the movie, he's like the Jonah Hill in real life. So Immersive Insights teamed up with Ari to see if we could understand the way that he analyzes his data, to see if maybe we could help him improve the way he analyzes his player data. And with a couple of immersive visualizations and IBM partners, we were able to generate several prediction models. When Ari tested out Immersive Insights for the first time, he started off by saying how impressed he was by the potential of the tool. He spent the first few minutes walking around the data, asking questions out loud, and making some changes to the visualizations. He said it's important for him to consider several factors about the players at once, like whether the pitcher is left-handed or right, whether they've had prior injuries, what their salary expectations are, and what their predicted performance looks like. He was delighted to see that with Immersive Insights, he could visualize 6 visualizations worth of data in one. And not too long after, Ari actually discovered something big enough that the next day, his team signed a player's multi-million-dollar contract. Not to mention, just in time for the last day of free agency. Here is an actual picture of what Ari's original strategy looked like when he analyzed his data. It's complex and painful to look at not to mention extremely time-consuming. On a regular basis, Ari would have to work with these long spreadsheets in order to generate any sort of understanding. Using Immersive Insights, Ari created a substantial change based off of findings that he generated in a matter of hours. What I find to be the most important part of his story is that if Ari had used his original strategy, he probably still would have discovered these insights eventually, but he wouldn't have done so in time for the last day of free agency. So now I'm going to walk you through what Ari's exploration process looks like when he uses Immersive Insights. So let's imagine we are Ari Kaplan. We want to find the right player for our team. I'm going to start by opening up the app on my iPad and logging in as a guest. Now, the first thing I'm seeing is a list of visualizations to choose from, and in this particular situation, I'm going to choose the visualization that shows me the players' predicted performance versus their salary versus how much they've played within the last year. It's also color-coded by the number of throws each player had. Seeing this information in 3D is so valuable. It's easier to understand, and when I see the entire plot laid out like this, I can quickly start picking out outliers and identifying more relationships. So with Immersive Insights, we can visualize all of these dimensions at once. Now here in the legend, we've chosen to use color to differentiate the left and right-handed players. Let's say I just want to see those left-handed players. Now, I want players with high performance for a good price, so I'm going to filter in on those dimensions. I want to see the players who have pitched a lot of games, those with a higher salary, and those with a good predicted performance. Now I can actually look at and walk around this particular subset of the data that I'm interested in. And I can go in and select a few of those specific points as well. Now I'm going to open up the collection box to see some more detailed information about the players I selected. I'm seeing they're only being identified by a number, so I'm going to go into the category selector to reveal their first and last names, as well as some other information I want to see about them. And now I can see I've chosen Hill, Gonzalez, Miley, and Lester, 4 Major League Baseball players who fulfill our criteria. Another option I have is to change the category of each axis and see how the plot transforms based on these alterations. I'm going to go in and change the x-axis to age to see how the players behave within these parameters. We can also add more visualizations to our environment. Maybe we want to do a side-by-side comparison or analyze a different section of the data set. As you can see, this works really well for comparing 2 or more visualizations, thanks to the multidimensionality we're being given to see this information. This is one example of the features we've incorporated so far in Immersive Insights, and this initial go-to-market functionality is just the beginning. Now, you may have noticed in these various examples I've shown that we've used different devices to show our product. This has been something that's been changing throughout our entire process and will likely continue to change as time goes on. IBM is a hardware-agnostic company, so we're constantly exploring all options available to us. Our choices were either deploying the product to an AR headset or using AR Kit, which provides the experience on iPads and iPhones. We wanted to find the best device that provided this immersive experience we were trying to create. We started off using the AR headset because it is on the cutting edge of AR technology. The headset was really exciting. It's engaging, interactive, and best of all, hands-free. We used the headset for about 8 months, but after some time, the cons started to outweigh the pros. The headset was pretty heavy. It provided limited peripheral vision, and it had low-quality graphics. In addition to this, the devices are really expensive. So while the headset was great for getting that immersive part of the experience we were trying to create, we also had to prioritize simplicity, accessibility, and ease of use. For these reasons, we temporarily paused our efforts on the headset and began developing the app using AR Kit, which we found suited us really well. The graphics looked much better, people seemed to understand how to use it faster, and what's really important is that a lot more people have access to iPads and iPhones than these expensive AR headsets. Although this is not a permanent solution, we think right now it's really good for helping our users transition into that AR environment and get comfortable using 3D. And our long-term goal is to provide the experience on a headset, so we plan to transition back to that as they continue to evolve. At this point, I'm going to hand it over to my colleague Reena to talk about some challenges we faced as designers along the way. Thanks.
All right, so designing an AR app is uniquely challenging. I mean, is there anyone in this room that sort of feels like they've got it all figured out? No takers? Yeah, I mean, the truth is that this is really an emergent technology. So as designers, there is a lot that we are still working to figure out. And sometimes these are really fundamental things, like how do we help our user navigate our experience? How do we get them to understand the range of actions and possibilities? How do we do things like display visuals and text? How do we gesture? How do we manipulate objects in that 3D space? So today I want to share some of the challenges that we've faced as we've designed our product, as well as the learnings that have come out of working through these various issues. But before I get into the specifics, I want to sort of step back for a moment and talk about why this all matters, about the bigger picture here. And I want to emphasize the importance of design systems. So design has always largely been about systems, because defining systems allows us to create products in a cohesive, scalable, and repeatable way. So things like socket wrenches, measuring spoons, electrical currents, they're these common understood standards. And what they do is they allow us to create, communicate, and transfer ideas. Now, when most people think about design systems, they think about the parts, right? So these are things like components, master libraries, downloadable resources, those kinds of things. But a good design system is never just about the parts. They're important, of course, but they should always point and push towards another goal, that goal being the experience. So the guy driving this car, he's not thinking about all of the pieces that make up his car, right? He's thinking about his line on the next turn. He's thinking about when to brake, when to shift gears. So a good design system is always about the experience. You're trying to make someone's job faster and easier. You're trying to help them achieve their goals. So at IBM, we began this process of establishing a design system a couple of years ago. And it's really been this huge company-wide multi-year endeavor. And, to give you a bit of context, at IBM, we have more than 1,600 designers. So we are actually the largest corporate design team in the world. So as you can imagine, having a good design system in place is really crucial. It helps us reduce inconsistencies in our work, it improves our processes, and it ensures that we have a cohesive user experience across all of our many different products. So now our team is also trying to do the same thing for AR, coming up with guidelines and systems and best practices. But as you might imagine, it's really challenging because this is a technology that is continuing to evolve on an almost daily basis. And unlike 2D product design, we don't have this bank of established design patterns and conventions to fall back on. We're sort of inventing things as we go, right? But through a lot of trial and error and just constantly iterating on our work, we are sort of starting to get that sense now of what works and what doesn't. So we'll be going through some of that today. So let's start by talking about navigation. Now, when we discuss navigation, I think it's worth noting that there are really two layers of design going on here. So the first piece that we have is the app design. So this is about things like menus and settings and really those 2D UI elements that help you navigate the overall experience. The other piece that we have is the experience design. So this is about manipulating those 3D objects, in our case, the data visualization. So this is about navigating within the experience. And it's really important that both of these pieces work and that they really fit together for the user to have that seamless experience that we're going for. But the thing is, it can be really challenging for a user to understand the range of actions and possibilities that are associated with a 3D object. So if we look up at the screen and we see this app, we see this cute little dragon, we might wonder, what are the interactions here? What can we do? What can a dragon do, right? Can he fly? Can he breathe fire? Can he lay an egg? Having never met a dragon before, as a user, you have to make some guesses. You have to make some assumptions about the possible interactions. But let's say I were to replace that dragon with something more familiar, like a car, for example. So immediately the interactions start seeming more apparent, right? So this car probably goes forwards and backwards. It probably accelerates and brakes. Most likely it doesn't breathe fire or lay eggs or fly, right? So when it comes to 3D objects, a greater sense of realism affords a clearer sense of the possibilities. Now, of course, that's not to say that having a fictitious 3D object is inherently a bad thing. That cute little dragon is actually part of a very popular game, and there can be some genuine delight in discovering all of the cute things that he can do, right? There's some intrigue there, it's fun. But you do have to consider the goal of your product, and our product is not a game. Our product is a tool for data scientists to speed up their data exploration process. And it's been really challenging because a data plot like this is not a familiar physical object. So we have to help our users figure out what they can do with it. So we've had to spend a lot of time really thinking through the beginning of our experience. What is it like when someone first launches our app? How do we help them avoid frustration and really jump into their workflow and start being productive? So there are a couple of different strategies that we employed. One of the things we did was, as you can see, we've kept our interface very clean and very simple. We've limited the number of interactions, and we've also broken them up by task. Now, this is not to say that our product isn't robust or sophisticated, but just that there's no need to present all of the complexity right up front. So I don't know if any of you have had this experience where you walk into a restaurant and you're confronted with a menu that looks a little bit something like this. And then, a minute later, someone comes around to take your order and you're kind of overwhelmed by all of the options. So you're like, I don't know, come back to me. And then you wait for all of your friends to place their order. And then you just copy whichever one sounded the best. And then afterwards, you start second-guessing yourself. You're not sure you made the right call. You're thinking, geez, maybe I should have picked the chicken, right? So it's the same notion with product design. You don't want to overwhelm your users with buttons and choices and just a smorgasbord of options, right? This is one of those cases where less is more. So we decided to get around this issue by having two collapsible navigation menus. So we have a menu on the left that is for our global actions. So these are things like menus, settings, pulling up new projects, new visualizations, those kind of things. And then we have a menu on the right that is for those more context-specific actions. So these are the things that relate to manipulating a 3D object. So these are things like legends, filters, anything that you might want to do to that data set. We also chose to make our menus collapsible. Now, if you think about an AR experience when you're wearing a headset, you have a very big field of view, right? You might not want to use that whole field of view for many different reasons, but you essentially have 360 degrees of space to work with. Well, with a tablet, you are already working with this kind of limited window into the 3D world. And we really didn't want to clutter up the viewing space with lots of buttons and tools. So we chose to make our menus collapsible so we can really give back that extra screen real estate to our users so they can use it to focus on their data exploration. So another way that we help our user is by providing some guidance. So we use simple visual hints to reduce friction during that initial experience. We didn't necessarily want to force our users to go through a long onboarding tutorial, nor do we obviously want to force our users to have to read a manual or anything to figure out how to use our product. But we want to provide just enough information so our user can see the available options and jump into their workflow. Another way that we help our users navigate is through strategic use of gaze. So as Jenna mentioned, our user might want to pull up multiple visualizations side by side so they can compare and contrast different data sets. But of course, if you want to manipulate one of these visualizations, make any changes, you need to select it. Well, we can help our user by using gaze and camera tracking to just see which visualization they're looking at and allow them to interact with it. So we're effectively skipping that step of having the user make a selection. Now, of course, if you're going to do something like this, you want to make that affordance apparent in some way. So for now, we've just gone with a simple text label. So you'll notice when the camera switches over to the other visualization, the label at the top actually changes to show you which data set is in a selected state. But you can use any number of other means of making this affordance apparent. You can use haptics, you could have your objects glow or pulsate or bounce. It just depends on what's appropriate for your particular situation. So, individually, all of these different strategies might seem kind of relatively minor, but collectively, they really nudge the user towards a smoother workflow and help maintain the magic of the AR experience. So Jenna already described how we started developing our product for head-mounted displays and then transitioned to developing for touchscreens. And that transition came with its own design challenges, because we went from manipulating 3D objects in a 3D space to manipulating 3D objects on a 2D screen. And that creates a kind of disassociation, right? We needed to make those gestures and interactions feel really natural and intuitive. But we found there was often a gap between the user behavior that we anticipated and the actual user behavior. Now, if you think about an AR experience in a headset, there are some specific gestures, like this bloom gesture, for example. Really, there's a whole new set of gestures and interactions that a user has to learn. And I think most users are aware of this because putting on a headset is such a novel experience that they tend to recognize they're going to have to move their hands and their bodies in a bit of a different way to navigate this experience. Now, I want you to take a look at this video. So this is a recording of our immersive experience when a user is wearing a head-mounted display. Now, what do you notice? Do you see how the user is approaching the visualization? They're walking around it, observing it from different angles. Now, this is a really important behavior within our product. We want our user to walk around the data, to look at it from different angles, because that's really how they're going to find the patterns and the relationships and uncover interesting insights. But the fascinating thing is that when we transitioned to a touch screen experience, our users didn't walk around the visualization anymore. Instead, they stood still and they tried to pinch and zoom and rotate the 3D object on the screen. So in other words, they really defaulted to the traditional phone and tablet behaviors that they were used to, right? So the actual user behavior really deviated from what we had anticipated based on our experience with the headset. So as a result, we ended up having to include touch-based rotation within our product. To give you another example, this is the original method we had in place for repositioning a visualization. So the user had to click that magenta button at the base of the plot, then they move their visualization, and then they click the button again to exit the repositioning mode before they can do anything else. Now, to users wearing a headset, this interaction seemed intuitive enough. But anyone that was using a tablet really struggled with this interaction. it was hard to discover, and it was hard to use. Can you guess what they all wanted to do instead? They wanted to drag and drop and pinch and zoom. Yeah, traditional touch screen behaviors. So rather than fighting it, that's exactly what we ended up letting our users do. And I think this was a really important lesson for us, that you have to bear in mind the mental model of mobile users when you're designing a mobile AR experience. So of course, we still want to find ways of encouraging movement, of encouraging our users to get up and walk around the visualization, but we also really have to consider people's natural instinctive behaviors when they're using a tablet and design for that in mind as well. So another design challenge that we've had to grapple with as we made this transition from headsets to tablets is the question of 2D versus 3D. So just because something can be in 3D, should it be, right? So with our headset experience, of course, we had all of the controls in the 3D space because that's kind of where they have to go. We did have a voice assistant as well, so that's the green circular icon you see in the top left. So that kind of created a more multimodal experience, gave users another way of interacting. But essentially, all of the controls were in that 3D space. But when we transitioned to the tablets, we really started, asking ourselves, really questioning every feature, every piece of functionality, and, really asking, does this belong in 2D or 3D? Because, having something in 3D, it looks pretty cool. Yes, it's kind of more fun. But at the end of the day, this is a serious tool for data scientists. And one of the key things a data scientist needs is precision. And, when you're doing data exploration, data analysis, there's just a certain level of granularity that's required. But we found it was often very tricky, just kind of very finicky to make these precise adjustments in the 3D space on a 2D screen. So we actually ended up having to relocate a lot of our adjustment tools to the 2D UI. So this filtering tool that you see up here is an example of that. But it's been a very tricky sort of thing to have to balance because, on the one hand, we kind of know that having a lot of 2D UI elements like this can sort of break that sense of immersion that a user feels when they're having an AR experience. But on the other hand, things like precision and utility and productivity, they're really important to our users as well. Our users need to be able to complete their tasks and achieve their goals for this product to be any use for them. So this is something that might continue to change as the technology evolves, but it's definitely been a very tricky thing that we've had to balance. So I want to switch gears for a moment, and I want to ask you guys, what stands out to you when you look at this photo? Anyone? Yeah, exactly. What stands out is that this is a really bad photo, right? Yeah. Now, of course, I could have shown you a nice, clean marketing image that looks really great and shows the visualization nicely, but I deliberately wanted to share this with you because I think it illustrates the reality of using our app, right? So this is an app for data scientists, which means most people are going to be using it in their office. And, I don't know about your desk, but I know my desk and a lot of the people that I work with, our desks are pretty messy and they're pretty cluttered and they look something like this. So it's really important to acknowledge with an augmented reality experience that we can't control the scene, right? We can't control the scene. So although it might be really nice if our user took their visualization and placed it neatly on their desk, that might not be what actually happens. So maybe their desk is too messy, or maybe if they put the visualization down on their desk, they'd be looking down at it, and that's not the optimal viewing angle. Or, maybe they're sitting in a tiny cubicle or working from a cramped airplane, for all we know, right? So for now, we've just given our user the agency to place their visualization wherever they'd like, even if that's kind of floating midair like this. And I think to sort of hark back to what I was saying earlier about, that idea of dragons and cars, I think because a data plot like this is not a familiar physical object with these very defined physical characteristics, our users are willing to suspend disbelief about gravity. So you couldn't, for example, have a piece of furniture like a couch floating midair, but a data visualization, most people are kind of okay with that, right? At the end of the day, when you're designing an AR experience, these are first-person experiences, right? We're designing an experience for someone else to have. So we kind of have to relinquish an element of control. We also need to think about the context in which our user is having this experience. So unlike an entertainment AR or VR product where, maybe a user might engage for these kind of short gaming sessions, we know that with our product, our user might actually be sort of exploring their data for quite a while, right? And we also know that they're more likely to be using an iPad rather than a phone, just because the added screen real estate is really better suited to this kind of task. So when we start kind of piecing these insights together, we begin to realize that our user is probably not sort of standing there with an iPad out in front of them like this for hours on end while they explore their data. So we need to account for things like user fatigue because that affects the design. So it's really important to ask questions about your user's context, right? So are they sitting or are they standing? Are they lying on their couch? Are they walking around outside or doing something really crazy like riding a bicycle? And is your user going to be comfortable using your experience? And if they're not going to be comfortable, are they able to adjust or manipulate the content in some way to make it more comfortable, to make it sort of suit the way they're actually going to be using your product? Now, I think this sort of inability to know your user's scene, to really know the context, kind of brings me to another design challenge that we face when designing an AR app, and that is displaying text in the 3D space. So those of you who are working on this might have found by now that there really is no magical color that works well for text on every single possible background. So this is especially problematic for single-colored free-floating text like this because your user might be in a room that's very busy or very patterned or very cluttered, or maybe the walls just happen to be the same color as the text that you've chosen, like in this example. So there are a couple of different strategies that we've sort of explored to try to get around this issue. So one thing you can do is you can use a translucent overlay across the viewing field. So this kind of creates a bit of a barrier between the background and the text and helps increase legibility. So this was an exploration we did for a possible menu. Those kind of glass cubes that you see are meant to be representing our 3D visualizations. And you can see it works pretty well, like the text is quite legible, right? But this might not be a viable option for every situation because maybe you don't want to obscure your background, right? Or maybe you need the text to be present for a long period of time. So we had some instances where we needed to display text as a label for the axes on the various scatter plots. So we needed to keep exploring other options. So another convention we commonly see in a lot of AR apps is to use a card around the text. So obviously this is legible, but I think one thing to note here is that the text really feels overlaid, right? So it feels like it's attached to the 2D UI, to the screen. And I think a part of what's contributing to that here is the opacity of the cards. It's just kind of something we tend to associate with 2D UIs. So let's see what happens if we make this translucent. So we've kind of added that frosted glass effect. So now we get a little bit more of that feeling that this belongs in the context, right? It kind of suits an AR 3D app. But it still feels a little bit like the text is sitting on our screen. And you'll notice all of those cards are the same size. So that's really contributing to that feeling here. So let's see what happens when we vary the size of the cards. So straight away we start getting a sense of depth, right? Some of those cards feel closer to us, some feel further away. Now this is feeling a little bit more like, okay, maybe it belongs in that 3D world rather than just sort of floating on our screen. So another example that we've seen done pretty well, this is the Metro Paris app. So this is an app that's designed to help you find subway stations around you in Paris. And you can see they've done a lot of the same sort of things that we just talked about. So they have a card around the text, they've got a bit of a translucent effect, they've varied the size of the cards, and then they've added another element, they've angled the cards as well. So now not only do we get that sense of depth, but there's also a sense of perspective. You know, we really sort of start feeling like, okay, there are subway stations all around me, and some of them are closer and further away than others, right? So another option that we've ended up using quite a bit is to add a subtle drop shadow to the lettering. So having two colors next to each other just naturally increases the likelihood of the text being legible, regardless of whatever the background might happen to be. And I kind of like this option because it does feel a little bit less intrusive, perhaps, than some of the other options. So the text doesn't necessarily jump off the screen, but it's still legible. So I think this example with the text kind of really highlights the fact that there's no one right approach when it comes to designing an AR app. And I think, you know, if there's anything we've learned, it's that we really don't have all of the answers yet. You know, this is a technology that's just changing all of the time. So there's constantly sort of new questions, new issues, new challenges that we're having to grapple with. So there really is a lot of trial and error involved in this process, but we've really found that's the fastest way to learn and to make progress in this space. So I want to just kind of recap some of the key things that we've talked about today. So first of all, you really want to make sure you help your users navigate the experience. You know, I think it's really frustrating for a user if they kind of open up the app and they don't know how to use the controls, how to do anything. It really breaks that sense of presence, that sense of immersion that they feel. So you really want to think through what it's like when someone first gets into your product. Don't make everything in 3D just because you can. You know, I hope you'll go away and sort of think about all of the different features that you've got and really question, you know, is this serving a purpose? Is this adding value to the user in some way? Or have I just put this in here because it looks kind of cool? Remember that you can't control the scene. You know, with an AR app, a big percentage of what the user sees is the room that they're in, is the environment. And obviously we can't control that, but the more that we can understand about the user, about their environment, about the context, the better we're sort of able to try and design around any issues that there might be. Consider the existing mental model of mobile users. You know, people have been using tablets, touch screens, phones for quite a while now. So there are a lot of natural behaviors and a lot of things that we just kind of instinctively do. So even though you might want to encourage some other behaviors, you do have to bear in mind that starting point that people have when they pick up a touchscreen device. And fail fast and often. You know, this is one of those situations where you often don't know what's going to work, what's going to stick. So you have to just generate a lot of different ideas, try them out, test them with your users, because it might surprise you the way people actually react when you test your product. So, you know, as you can see, there are a lot of challenges, there are a lot of unknowns, but I think one thing is certain, and that's really that designers are going to play a critical role in making a lot of these important decisions that are really going to build the foundation for this new technology. And although the challenges might be different from anything we've faced before, ultimately we really rely on the same fundamental problem-solving techniques that we always have. And that is really digging deep to understand user needs, drawing inspiration from the world around us, and being prepared to fail over and over and over again until we get it right. Thank you. So yeah, if anyone has any questions, we'd be happy to answer them if there's a mic right up here.
Yeah, first off, thank you. Very great presentation. I probably spent more than I like my life, and I care to admit, staring at Excel, so seems very interesting. A couple questions for you, though. The first, if analyzing the data is one part of the analyst job, presenting it up to the decision makers is probably the other important piece. Are you guys considering that in this tool, and are there some presentation tools available in it?
Yeah, that's actually a really good question, and that's something that at first we were kind of working on both at once, and then we felt like we were doing both of those things adequately, and we wanted to do one really well and then focus on the other. So after we release this first version, we're going to start working on getting that presentation aspect of the app going, and that's actually one of the big benefits of having the headsets, is that you can all, it'll synchronize the room tracking, and everyone can be looking at the same thing at the same time from different angles. So that's definitely something we plan on incorporating.
So that leads into my second question. For the iPad application, is there a multi-user collaboration piece to that too? Can everyone be staring at the same data set?
I mean, right now there isn't, but that's definitely the goal, is to sort of have that shared space so that everyone can be looking at the same object and collaborating in the workflow.
Okay,
Yeah.
Thank you.
Love the presentation. Thank you. Design thinking, beautiful. One thing I thought was interesting was every time I would kind of come up with an objection, you would then say, well, here's what we came up with, and then we saw this and saw this. The one thing I didn't see, though, is after hearing you kind of say, okay, when we moved to tablet, well, we moved away from this spatial consideration and this spatial consideration and this spatial consideration. At what point do you say, well, we really aren't even doing something spatially? Why keep it in AR?
Yeah, I mean, I think it's a really good question, and definitely something that we kind of struggle with, because you're right that this is not the traditional idea that most people have of AR. We're not meshing a digital object with the physical world. It's not like when we see industrial uses where you've got schematics over a car engine and you're repairing it and that kind of thing. We are trying to look at ways of how we can mesh it with the environment more. But I think ultimately, we've sort of found that there is just something very engaging and intuitive about actually having the data in 3D so that you can walk around it and so that you can see it from different angles. And that's not necessarily something that you can get from a screen. I know there's a lot of 3D modeling software where you can see a data visualization on your screen, but we've had a lot of experiences where we've tested with, users, with data scientists, and they kind of, at first they're sort of like, oh yeah, this is cool, and then they sort of start walking around the data and they're like, oh my gosh, I just found something, I just found a correlation. And we've seen that happen over and over again. So there just seems to be something about physical objects that kind of helps humans just learn and engage. So so then it kind of just became that question of AR versus VR, which Jenna sort of talked through. But yeah, you're right, we're definitely working on looking at other ways of really meshing with the context, with the environment.
Yeah, cool, thank you.
Hi, great
Hi.
talk. I'm a big fan of putting 2D UIs into space, so great job there. Can you share a bit more about the workflow of your test user before they could see this AR thing? I think like a majority of like data visualization tasks, like the tedious one, have actually happened before people can see the visualization. Like what happened, like if I have like a huge spreadsheet, like do your test user like crunch them, like organize them in some way and put them in AR, or like you just give them these visualization in the beginning?
Yeah,
Well, we're making Immersive Insights a tool added on to this program called DSX, Data Science Experience, which now is changing, but so that allows data scientists to compile all of their information and export CSVs, and so they can do all of that, get all of that data in one place using DSX. And online, there's a button that's just go to Immersive Insights from here. So through IBM's platform is how they're going to be assembling all of their data.
Yeah, so the initial work of preparing their data, that can actually be done, with existing software, and then they can just take the model, and rather than just looking at it as a 3D model on your computer, you can take it and look at it in AR.
But they have to reduce like the data into 3 dimensions because that's what it's showing, right? Because
Oh, yeah. Well, so we're using WebGL to be able to preview the graph on the web before you push it. So you get to choose which 3 categories you want as your axes. And then if you remember from the demo, you can change them once you're in there. But yeah, you can either customize or we'll automatically select those 3 for you.
thank you.
Hi, thanks very much for this talk. I found the design path really interesting in the sense that I feel like you started with this high aspiration of having the users operate in 3D and walking around and discovering patterns. And then gradually, step by step, I feel that you ended up with an app that is not very different from the 3D rotating graphs that I've been using for 20 years. A two-dimensional display, I can grab a handle, turn it and rotate the data. In the end, you even got rid of the AR background because it's too much clutter. So how is this really, two questions. How is this really different from the tools that we've had for many years? And second, have you maybe learned something more about the users? Perhaps, the instincts of the designers from 20 years ago weren't all that bad. Maybe they're actually matching better what a statistical data analysis user wants.
Yeah. I guess to answer that first part of your question, it's challenging, and I guess Rome wasn't built in a day, right? So we still have those kind of lofty aspirations of really having, an experience where users can walk around their data. We're, as Jenna said, we're hardware agnostic. So ultimately, we hope that people can use tablets, they can use HoloLens, Magic Leap, whatever they want to be able to sort of just launch a visualization and experience it, right? But I guess a lot of it is technological constraints. A lot of times we want to do something and we try to do it, and then we just come up against these hurdles where the technology hasn't kept up, and that's actually kind of why we made that transition initially from the headset to the tablet, and it's sort of, we want to sort of just get something that's to start working and have our users use it, and then sort of, we have sponsor users, we try to see what use cases they're interested in and, their workflow, and then try to develop for those things as well. So, ultimately, yeah, our goal is still that kind of lofty goal, but it takes some time, right? I mean, if you think about the very first computer, it took up a whole room, right? And now we have more computing power in our pockets. So I think eventually we will get there, but it takes time.
It's true, but I feel like you've walked back to where, Excel linked to a 3D graph gives you a lot of the same functionality. So I feel like you've returned to perhaps what the users find more natural, actually, in their process of data analysis. Maybe you're actually responding to user wishes rather than limitations of technology.
Yeah, that's fair. In some aspects, we definitely have reverted back to those natural interactions, but in some cases, we actually ended up not using we kept the background the way it is. And it seems like each case we've been testing with sponsor users, we're finding these unique reasons that they enjoy using it in AR. And so this is actually a question that I asked a lot when I first started, is like, I don't really get why this is necessary. And my boss kind of said, well, nobody knew they needed Excel until we had Excel. So, it's a question that we do ask a lot, but as we're testing, we're just finding new reasons. Like, for instance, one user was like, I would love to be able to pin up these menus against the wall and make use out of my entire room. And that's something that we hadn't thought of, that he thought of, that could be helpful to other people. So as time goes on, we're finding more ways, but sometimes those going back to the way it was is the best way. I think it's a combination.
Great. Anything else?
You guys mentioned that the background could be problematic sometimes. Have you ever considered just transitioning this over completely to a virtual world, and what benefits that would bring you there?
Yeah, we've definitely considered that. One of the main things I would probably say is that usually people are using this app for hours on end. So it's kind of distracting to be in a virtual world. Like, you want to be present in your environment and know what's going on around you, and maybe even be able to use notes and stuff that you have on the side, which you wouldn't be able to do in virtual reality. And as I mentioned before, we're kind of finding more ways to actually use the space around us and make that more useful. So it has been challenging with the cluttered backgrounds and such, but we think that there are more pros in AR than in VR. I hope that answered your question.
All right. Well, thank you so much, everyone, for coming.